Hello and welcome to this Building Domain session as part of the buildingSMART International Standards Summit, Lillestrøm 2023. Thank you for joining. My name is Sheila Karailam and I will be your moderator today. Today's session is titled An Industry Forum Kickoff and Update from Norway. Our sessions will be hosted by Shelleyvar Backmoen, who is a Building Domain Steering Committee member. This session is scheduled to last 90 minutes with time for questions at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to our speakers, I would like to remind you that this is a hybrid event. For those online attendees, your microphones will remain muted for the duration of this session. If you do wish to ask questions, please use the chat box in the control panel. And for those of you in the room, please do try to keep any background noise to a minimum and raise your hand if you wish to make a comment or ask a question. I will bring a microphone over to you. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted. The process for their adoption is transparent, and standards that are developed do not favour any particular provider and are open, non-binding and accessible to all. Please take note of our antitrust code of conduct, which is up on the screen now. And on this note, I would like to hand over to Magne and Barbro.
Hello and welcome to our presentation where we're going to show you our digital twin proof of concept that we did using Autodesk Tandem. My name is Barbro Sæten and I work as a digital business developer at Multiconsult in Oslo.
My name is Magne Ganz. I'm working with digital collaboration and development in Multiconsult.
First off, we just want to present you some quick facts about Multiconsult in case you haven't heard about us. We are a leading firm within consulting engineers, architects, and designers in Norway. We have roots all the way back to 1908. Have been part of a lot of different projects since that time. We have a little bit over 3,500 employees, both in Norway and internationally, and provide a range of different services. We have 4 main business areas: buildings and properties, transportation, renewable energy and industry, and water and environment. And we are within what's called buildings and properties mostly. We have an international presence as well, not just in Norway. We're in different parts of Europe. One project office in Canada, some in Africa and Singapore. Our main office is in Oslo, Norway, but we have multiple offices throughout the whole country. And what we're here today to tell you about is our journey creating a digital twin proof of concept. Both how we built it, what we learned creating it, and how we're going to continue working on digital twins. And the journey that we want to start was that we wanted to define what it means and is to us and our customers, because what we saw was that there was not one clear agreed upon definition in the AEC industry. There were rather many different definitions. We wanted to take it from a buzzword to something tangible and concrete. And we wanted to test and learn the value proposition of different use cases within digital twin. And this is kind of the overall process that we used working on it: engage, align, execute, and evaluate. I will go through that in some detail throughout the presentation. And within the first step, we explored digital transformation as a whole, because before we went into a digital twin initiative, we looked really broadly at digital transformation, and the digital twin really stood out as a clear initiative. And then identify motivations for digital twin, identify possible use cases and user stories, and lastly, define a pilot project. And a little bit about the landscape that we saw getting started. Industry-wise, there were no common standards and few real-world examples as we saw it. There were some emerging efforts, but none that were quite ready. And technology-wise, there are of course many vendors of digital twin components, but not kind of the full package, and they're often proprietary. And an important thing to note before building a digital twin or starting your digital twin journey is that you need to know why you're doing it. What are your goals for creating this twin, and what are your ambitions? Which value will it create for you or your customers, and which needs is it solving? And also, who are the key stakeholders in this, and are they on board and ready to use this kind of technology? Because if not, it's hard to realize the true potential of this technology.
Yeah, so we started the journey back in 2019, actually. We just wanted to explore if we could connect the BIM that I mainly work with to live data from how the building performs. That was a scan to BIM, and we got some sensors from Telia, and we created an app in Autodesk Forge. We have a programmer at my department. And then it kind of stopped. We didn't really know how to go further. So we just, let it stay. But in January 2022, we had an initiative together with Autodesk. So we kind of reinitiated the digital twin thought. And throughout that winter and spring, we had a series of workshops, both with Autodesk and also some internal. So a little bit more about the testing we did in 2019. So we had our headquarters in Oslo. It was built before BIM was a thing, so we didn't have BIM for the building. So we did a scan to BIM on the fifth floor. And in collaboration with Telia, we got some sensors from them, 5 of them, that measured the temperature and humidity. And they also had an API ready for us. And we were already started to kind of build our own apps with Viewer in Autodesk Forge. So we managed to connect those pieces together and show live data inside the BIM. And from there, we hadn't really done all the things that Barbro said you need to do, what value will this create, and so on and so on. So it kind of stopped. But it was kind of first. And then there was a new beginning for us in 2022. We did some workshops, as mentioned. We had the first part was mainly like introductions, digital twin overview, looking at the landscape. We saw some technology that was presented to us. We did some industry mapping to look a little bit where are we at today, where would we be in a couple of years. And then we went on to try to clearly identify digital twin use cases. We did this by workshops with post-it sessions where we kind of brainstormed and tried to group similars together and so on. And from there on, we prioritized the use cases. After that, we had a series of internal workshops. First, we evaluated the workshops we had during the winter. Then we set new goals for where we wanted to go with the digital twin topic. And we saw that we needed to define a specific pilot. Workshop 2, we looked a little bit more on the data flow. We draw some sketches of system, and we tried to discuss how we could implement this. And as we saw in the next workshops, we had to identify specific components. Since for those of you who have tried, you will know that the digital twin is not an off-the-shelf product. It's a service, and you have to build it yourself. So from there on, you have to define the vendors. Who are you going to collaborate with? And from there on, we created a digital twin topology. So how do we define a digital twin? This is the kind of basic definition. We will go through other definitions as well, but this is the basic one. You need a physical object or a building or whatever, and then you need a digital representation of that object. And the last step, in addition to that, you gotta have a live stream of data that connects the two pieces together. And hopefully you could also do some simulation analytics and feed optimization routines back to the physical building. Me as a BIM specialist, I also see this from a BIM perspective. So in the early stages, we do a sketch or a pre-project, and then we develop something called Slim BIM. And for those of you who are familiar with level of development or model maturity index, that's about 100, 200, where the BIM represents the main geometry in 3D for the chosen solution. The model has not so much structured information, but good enough for an early phase calculation, maybe. And then you move on to detailed projects. You do the actual design BIM, where you do all the coordination, clash detection, quantities, and eventually you're at the point where you can do a more exact cost calculation, and you have all you need for construction documentation, whether you do it by drawings or build directly from the model. And as an engineering company like us, most often we stop there because both we or the client doesn't see the purpose of moving the BIM any further. But in some cases, we also do construction BIM, where parts of the discipline model are broken up to production packages that are adapted to the site logistics or prefabricate sections. Then it's built on site, and from there on you do something called an as-built BIM. And in most cases, going back to the MMI 400, that's just an MMI 400 renamed to as-built. So we cheat very often. But I would like to see that in more cases, we do the 3D scanning, we evaluate that with the construction BIM or the design BIM, then we update geometry as necessary, and also update with the specific selected products that are used. And then at the model maturity index 500, you can't really do much more with the BIM, but still you don't have a digital twin. So the next step is, natural step is to create what I call a facility management BIM. Some call that BIM level 1, but we call it a facility management BIM. Where you just link your model to a database or an archive where we have the operation and maintenance information. And the next step is what we tried to do in 2019, or succeeded with also, is to connect that BIM with the sensors, and preferably with the building operation system or the building monitor system. Then you have the lowest level of digital twin, and you can build on from there.
Yes, and when defining digital twin, as Magne said, you need to have some levels to define how you build further upon it. So you need to define a digital twin in different levels with increasing maturity, just like the BIM maturity scale that we just saw. Because since a digital twin is based upon or built based on needs, it will differ from which functions it contains and how advanced it will be. So you kind of need different levels to showcase that, and also to kind of speak the same language when talking about digital twins, because my perception of how advanced a digital twin should be will differ from how advanced you think it should be when you just say the word digital twin. And there are no agreed upon standard for this yet, but there are several efforts to create it. And these are 3 examples that we've seen. I'm not gonna go through them in detail, but we'll summarize them afterwards. And one is from Powerhouse here in Norway, one is from Autodesk, and the third one is from Sintef, which was presented to us at a buildingSMART digital twin workshop. Yeah, but the point here is that there are efforts to create these definitions, and soon we will arrive at a common definition. So these are the 3 summarized, since they are in fact quite similar. And at the first level, the lowest level, you have a digital model with static information, which is what we call in facility management BIM, not a twin yet. Because at the second level, you add the live data, and that's when you can call it a digital twin at the lowest level. And at the third, you add analytics and simulations, And on the fourth, you build upon that further with prescriptive analytics and things such as preventative maintenance. And at the last and highest level, you have a autonomous twin with decision-making abilities.
Yeah, and from there on, we need to look what exactly does a digital twin consist of. And throughout the workshops and the sketches that we did, we come up with this one that we grouped into different groups. So the first group is the static data, where we have the digital model that has the geometric representation and information that is needed to fit the purpose. And that can vary a lot. And then you have the operation and maintenance information. Could be an archive, could be a database, could be a lot of stuff. But the important thing is this is static, like in quotes, because you do remodeling of your properties, you do modifications, but the data is more static than the next group. That's the real-time data. That is changed every second. So in that group, you will find a connection to the building operating system or the building monitoring system, and also free placed sensors you might have around in the building or facility. Then on the right corner, because when you have static data and real-time data together, you have the lowest level of digital twin. Everything after that is actually just applied data, because you have now gathered your data in a database. You can show them in a BIM viewer and a dashboard in a good front-end solution, whatever that might be. There are several that are working on that at the moment. But when you have collected the data in the database, you can retrieve that data and you can do the next steps with sophisticated software, and you can feed information back. Also, you could imagine that some of the arrows here are two-way. So you can actually control your building from here.
Yeah, and when with the definitions in place, we'll take you through our proof of concept. And first, we set up some objectives to why we want to create this proof of concept. We want to get hands-on experience to learn what it takes to build a digital twin and what the value can be. We want to test and learn from real-life challenges, test the feasibility to see that it's possible with today's technology, gain a reference project, and that in turn to gain us trust from customers. Publicity to show that this is something that Multiconsult is doing. Also to create discussions, both with customers and internally to exchange ideas. And of course, we wanted to generate new business opportunities. And you can see on the right that this initiative really fits well with Multiconsult's digital strategy, with the subjects highlighted in green, which is build digital foundation, data mining, digital collaboration, and digital alliances and partnerships. And before building a proof of concept, we needed to map out the different vendors that exist within the sections of the figure here. And one thing we really looked at was the vendor of the platform that kind of binds it all together. We really wanted it to be open and not proprietary. And then we saw that Autodesk Tandem really stood out as a good option to test out.
Yes, a little bit about team and collaboration, because as you already have discovered, it is really hard to do this by yourself. You need to collaborate with somebody, because you don't have all the components, you don't have all the technology in-house. And for that, we move over to the align phase. And the subtopics of that is find use cases specific for the pilot, review existing data for the pilot case, and identify the partners we need to collaborate with, explore integration options, and then and also define high-level workflow. So how we identified use case, it was a part of the internal workshops that we had. There were two options that stood out. The one was what we did in 2019 with the scan to BIM of the floor and the headquarters, but that was only an architectural BIM. We knew that the building was going to be remodeled. We knew that we were going to exchange or replace the building operating system. But on the other hand, we had the office in Drammen. It was newly remodeled. We knew that there was a quite new building operating system, and we had all the discipline models for that building. So we went with the office in Drammen. And from there on, we had to do some more thinking about how can we convince the building owner to get on board with us. So again, new workshops, new brainstorming, had to try to map the business value for owner, for tenant, for operation and maintenance. That's the different colors there. And then after that, we placed the different business values on the levels of digital twin definitions. So if you do only the descriptive twin, what could you achieve? If you did the informative, what could you achieve, and so on. And then here I highlighted one from each group on each level. I don't think I will read this out here, but you can have a look at the presentation later on. So the case we went forward with was Strømsøtorg 9 in Drammen. The owner is Tikon. It was built originally in 1962 for Skoger Sparebank. It's 10 stories, 34 meters high. It's listed for historical protection. It was renewed in 2019, 2020, and during that process, it was BREEAM certified. Their architect was DRMA. And the old building was stripped down to the concrete, and the concrete was scanned. So that's the scan to BIM part. And then everything was kind of a new project from there on.
Yeah, the situation for Tikon is a typical one for many building owners. They have multiple systems to log on to get information about their building and its performance and operation. And maybe in their day-to-day operation, they don't have time to log on to all these different systems to get all the data that they maybe want. So with a digital twin, you really get to optimize your operation by having all of this information in one interface. And therefore, you can really increase your efficiency by having the speed and ease of access to all of the data. And also, it makes a better tool for decision making. For example, with sustainability and energy considerations, when you have all the data connected to each other in a twin, in a context and visually presented in the model, you get a really good view of all the data when you're actually making the decisions. And you also get the opportunity to get actionable insights and be able to set measurable goals. And these are the systems that exists in the building now. They have one system for static documentation and tasks, which is Properly. And Svegon Connect is the management system for ventilation. And Gecko Cloud is the management system for heating and plumbing. And as Magne has touched upon, when establishing a digital twin, you need to collaborate both with the user or building owner, but also with the vendors of the different systems and components that are to be included in twin. And so with Tikon, we had an onboarding meeting and got access to all of the building data. And we chose to talk first with Svegon, and we explored common ground for establishing this digital twin, and I really wanted to get on board with this project. So this is a high-level topology of the proof of concept. This is the systems that we chose based on what we saw as the value and need for Tikon. We had documentation from Properly LinkedIn and the live data from Svegon, the vendor of the management system for ventilation, which then included data on CO2, occupation or presence, air, moisture, temperature, and airflow. And then, as Magne said, we had the BIM. And all of that was gathered in the digital twin. And this proof of concept exists within the 2 first levels of the digital twin maturity scale, with the static information and the live data. And just to show that digital twin is not an out-of-the-shelf product, Svegon had to do some minor development themselves, but are now posting the data into the digital twin platform.
Yeah, and then we move on to the execute phase, where we actually connected the dots together. So we created a facility in the digital twin platform. To do so, we created a facility template and the parameters that was needed. We classified the assets, we added parameter data, and we connected to sensor data. And then we were able to trial and test this use case. So this is just a picture showing that when you have your building in tandem, you can, of course, create different save views. If you're interested in doors, you can select them and create a save view for that. If you're interested in the HVAC system, you can create a save view for that. There's also possibilities here to have an inventory table on the bottom of the screen, like the ITO you can see in Solibri and such. And importantly, we had to upload our own classification system. We used the Norwegian standard 3451. That was not something that Autodesk had ready for us, but it was quite easy to make an Excel sheet of that and upload that to the solution. Unfortunately, these IFCs were not pre-classified. Often that is done by the designer during the design phase. In this case, I had to classify the components myself inside Tandem, but that was also possible. So it shows flexibility, where it's not like if you haven't classified your model during the design phase, the digital twin solution says, no, I won't take this. It just says, bring it on, we'll fix it. When you have classified, you have all the possibilities with filter, coloring, isolate based on where we are at in the structure, in the hierarchy. As you can see in the yellow box over there, we have added some parameters that we think are necessary in this proof of concept. So we have the product number, the product name, and the link to the datasheet improperly. So we don't transfer any data from the other systems that they have. We don't replace the systems that they're already having. We're just connecting them together. So when you click on this link, this datasheet will just appear directly without further log on to any other system. And if they should replace this ventilation valve with some other product, the building owner or the maintenance team can easily correct these values themselves. You don't have to go back to the guy that sits in Revit. He has to do something and then export a new IFC. No, you can manage those data directly here. Just another example, doors, bunch of other parameters like acoustic requirements, fire requirements, and size. And here we had chosen to link to properly at a higher level, so not directly to the PDF, but so you can scroll through all relevant PDFs for that building number in the Norwegian standard. And finally, we have connected the live stream of data. So the sensor is visualized by a green dot connected to a room. And if you click on that, select it, you will see the data for that point of time. But you could also see on historical data and choosing the time span you want to look at. There are also some dashboard possibilities, quite new ones, so it's not that developed yet, but at the moment you can see the parameter completeness and the classification status completeness, but more will be added here soon. To summarize, we have created a video. It should originally have a background sound. Forgot to turn that on the PowerPoint, so I will just talk through this video. So this is just showing live stuff, what I have shown on the stills. If you browse through your classification, you can colorize and you can highlight, turn certain parts on and off. Not revolutionary, but useful. Down to where are your panels for fire extinguishing. Then we look at the 8th floor. This is my office. I sit here on a daily basis. Not normally in a wheelchair, but that was the architect's choice. So when you click on the link, the datasheet appears. You can browse here. For instance, you can have a track on how many cable is on the cable bridge, and you can adjust that as you put more cables on or remove some cables if you like. Yeah, there are endless possibilities. You can have a view over the rooms, and you connect typically sensors to rooms, but you could also connect sensors directly to assets. You can then do different charts for humidity, occupancy, and all the data that you have, and you have nice colored rooms. Or look in specific detail on one specific graph if you want to do so.
Yeah, so now we're at the last stage, evaluate, and this is where we are now, currently, and we'll continue working. So we're not done yet, but the last step consists of to share interim results, collect feedback, enable further testing with customers, and look at digital twin as a deliverable. And so far, we are very happy with the results of this proof of concept. We reached all of our objectives, really learned a lot about the technology and the process around it. And we also shared our story and the results and gained really positive feedback so far, both internally and from customers in general. And it even sparked its own strategic initiative promoted by our CEO, Kristian, which is a big thing for us. And when collecting feedback, we also it has sparked a lot of really good discussions. For example, from our colleagues at Multiconsult, which represents a lot of different disciplines, we have been discussing how we can put together a multidisciplinary team to create the best digital twin service possible. And we have a lot of customers or building owners reaching out, wanting to get some help on their digital twin journey and know how to build a digital strategy as a foundation for that. And also from the market in general, getting opportunities to speak at events such as this one and talking to even more people. And when with the customers reaching out, we're going to continue testing with new projects and pilots. And we see that we really gain trust by doing this proof of concept. And we have learned how this process needs to be done and gain insights on methods. Because every project is unique and has different needs. So you need this proper process in place to first discover these needs and ambitions and benefits, etc.
Yeah, and then we are looking for that digital twin as a deliverable for a consultancy like us. And the POC has given us something tangible to discuss, like how can we offer digital twin as a deliverable? Which disciplines should we involve at what stage of the process? And also, as we've seen from the building owners or property developers that have reached out, we see that they are interested in digital twin, but very often they don't have a holistic digital strategy for their company from before. So that's where you need to start, and we can help with that too. And also how can Multiconsult expand our business to the operations phase? Of course, we have some at our office that are working on the operations phase, but we see that there are more out there that need to be explored. So what does this all mean? So from a sustainability perspective, the digital twin can help you to establish a baseline. There's not all the time you have all the numbers and all the data to establish a baseline, and digital twin can help you with that. You can monitor, measure, and you can optimize. The digital twin can help you with component mapping for reuse or for circular economy. You can have an overview over the embodied carbon from production and transport, and also material passport for recycle and reuse. And basically, you get insights based on data. From a property management perspective, you will transition your project or your whole company to a more data-driven workflow. You can monitor your facility remote and real-time. It has ease of use and speed of access. You will definitely improve your efficiency. And maybe your new project, you have invested a lot of money in making the BIM, then why not take it from LOD 400 and all the way to a digital twin? And then you get insights based on data. The road ahead, as mentioned, further test and validate the current POC. We are just on the first steps here. There is a lot more to be done. We want to evolve the POC with more functionality. And also, the POC is on a small part of a building. It's not the whole building, it's not the whole system. Of course, we want to scale this in preferably paid projects. And from there on, continue to evolve digital twin as a new business opportunity. So yeah, that was all from our end. Thank you for being here.
Thank you, Magne and Barbro. We will take a very short 3-minute pause while we set up the next demonstration, if that's okay. I think we'll get started, Ole. So over to you.
Thank you. Yep. My name is Kristian Kvarsvik. I'm the managing director of a company called Rendra, and we have a product called StreamBIM. But what I'm going to talk to you about, today is some hospital projects, and one in particular from a hospital owner, Helse Bergen, which is West Coast Norway. And this is not a proof of concept. This is a project that started many years ago and is being handed over as we speak. BUS 2, it's acronym for Children's and Youth Hospital, stage 2 of that project. The project was initiated already in the 1990s, late 1990s, and stage 1 was handed over in 2016. And as mentioned, the stage 2 will be handed over right now. So the project is this, it's called Glassblokkene, the glass buildings, and the one in the front is stage 2, the one in the back is stage 1. Stage 2 was approximately 50,000 square meters. It was also a project with ambitions of no drawings. They were going to produce everything based on models, BIM files. Altogether, it was 76 different design files, different disciplines, and that's approximately 12 gigabytes of IFC data. It's also a lean construction project. where they use TACT modules and principles of that. This quote down here is from 2015, but it says that they had high ambitions for digital collaboration, and I want to emphasize this driftbarhet, which is maintainable or maintainability. So they had a focus on that the data set they were handing over from the project should be able to maintain and use as basis for maintenance and operations. Important also in this project was the contractual, the legal parts. So what they said here, the changes to the standard contracts, is that this sentence here was quite important. Everywhere you as a contractor or as a designer read the word drawing, you shall read that as BIM, which means that the model was the contractual document here. It was not drawings. And that's how the world works. You become good at what you're measured by. So if the legal document is the model, then that's what you become good at. If the drawing is rated above legally, the drawings will become good. So I think that's an important aspect. They had a process they called 14.0, but part of lean construction is that you want to improve. So it was extended first to a 17.0 process to a 20.0 process, indicating that before they start production in an area of the building, they should do something 20 weeks before they start production. And then you have different steps here where you hand over the data set from the design over to the contractors who's supposed to build. Important, again, 4 weeks before they start building, all the product documents should be handed over and linked to the model through a database. And that's not often you have products available already before you start building. This process is kind of interesting to dig into, but it's part of the lean principles they are using in this project. I will not spend too much time on this, but most of, or all of these steps, 14 weeks, 6 weeks, 4 weeks, 3 weeks, 2 weeks prior, had some milestones regarding documentation. And this is weeks before you build. So the final step, 2 weeks before you start building, the documentation should be approved by the maintenance, the technical department of the maintenance of the building owner. So they approves that everything is in place. Yeah, so talk about building information and this illustration from the ISO 19650, where you see the data set just builds up quite stable up here with the graphical, the non-graphical, and the documentation on top of that. And then no data loss. This is the handover. It just slides right into the facility management stage. It's perfect. And as Magne also indicated, you can have a construction model, you have a design model, you have a maintenance model, but it's the same data set. It's just different views of the same data. I think that's important. And there's a lot of people that talk about this as a common data environment. And what does that mean? Well, it means an environment. It's not a software. It's an environment where software can talk. The important thing for both the project, but also for facility management, is that data is maintained one place. I worked at the Oslo Airport Terminal 2 project. And in that airport, there are 15, 20 different systems they use in the maintenance stage. And none of them are talking together. So you maintain data 15 to 20 different places. And when you have a facility of that size, it's not possible, which means you get crap data. People stop using it, even more crap data. But you need to maintain the data one place. So geometry is owned by the BIM authoring tools. Databases can own other pieces of the data set. Task decisions, documents, the building automation system, they own the signals or the live data, as Magne and Barbro just showed you. Maintenance, intervals, history should be owned there, but it should be available for those business processes out there that need those data to actually perform a task or a process. The simple setup, it's very simplified, but how they handle it or set up the project in this case was that they established this client requirement database, but that's also a project information management system and an asset information management system. That was listening in to what happened in the design files. So they tried to capture data when it occurred. So when the electrical designer put a light fixture in a room, it was reflected here when you synchronized. So you had an instance in this database, and what they got in return was a classification, an ID, an asset ID. And they used the same IDs through the project as they will use in facility management. And then all those objects, including IDs from the database, was published into the user interface where people were working with the building data. I'll stop sharing there and I'll sit down and I'll show you a few of the effects that you get from that. Yeah, so this is the hospital, 50,000 square meter, 76 different files put together, and this is an interface that I actually made for the handheld devices. So you should use your tablet or phone, but you can also use your desktop like I'm doing now in a browser. But all the objects that you see here, there's quite a few of them. They're linked to the database as well. So what happens if you go in here and select an object here, they have some structured data. And these parameters here, they're managed by the database. So you have a configuration between the database and the Revit file, which means that you as a client, as a building owner, can control what parameters go into which shared parameters in the design files, which means you have full control of the data that comes out. And you have some global properties here, but they defined the four most important ones that should be global for all objects, independent of discipline, and also the process related. There's 5 more properties here. And then you have a discipline specific, where you can move some add-on. But it makes it predictable for software like ours and everything that comes downstream from the design file. The point here is that this ID is a rule-based generated ID based on a standard. For those of you that saw Sten's presentation in the previous session, is generated based on the BIM, the data model of IFC or BIM, and rule-based generated by the database. So if we do a lookup here on the database, this enables communications over APIs. So this string here, that's just a type, UP002T. That's this design type that has a specific performance. It has this geometry. The 110th one that you place in this facility, which might be exactly this, is unique. So this is the 110th of this type generated. When you in Revit say, okay, so this is connected to this electrical panel through a Revit circuit or a system, then you get the full string. So that's a very simple rule, but it means that when the electrical engineer does this in Revit, synchronizes with Office, he gets this back, he has enabled a communication between different software systems. So what we do basically, we just throw this ID against the database and say, show us the data you have on this. And 4 weeks before they started producing, the product was already in the database. So those installing here, they could do a lookup in the database from their phone or tablet, and they can go in here, they could check out, okay, is there a product data sheet, is there installing instructions, whatever could be available here already before they started installing. And another cool effect about BIMifying this classification is that if you look on this code UP002T, it has 2,599 occurrences. It's a corridor lighting. But it means that when they added the product on the first part of, or the first control area where they started production, they could say, well, we selected the same product for all those occurrences. And they documented it one place. So it means when they first completed documenting the first area of the building, they already documented most of the other products for the remaining areas of the building. And if you want to see what a control zone looks like, this is another one for the production model. If you select the control area, you will then find all the objects that are supposed to be built by a train coming through with takt, for those that are familiar with the terms. But this is the piece of the pie that will be produced in this zone. And you can also easily figure out, okay, so what kind of objects is it that belong to my contract? Because if you select the property instead of the specific value, you list the values that this property has. So if we take 302, for example, that would be the mechanical project or objects. And you see, okay, so these are all the objects that I, as a mechanical contractor, will deliver in this area. So when you have structured data, it enables quite a lot of grouping, filtering, easy views. It's not predefined views. This is something you derive yourself as a contractor out there. So you turn it around from a push-to-pull situation where you can derive those data quite easy. And of course, one click and you have your ITO for those that uses Solibri. You can add the properties you want, easy export that, and even make a dashboard of that. So you have a live view of your quantities. Now, Sten also mentioned this about modeling a tag in the 3D. If you have those good data here, you can easily find all objects that are selected to a panel. Let me find a panel which is slightly more complex. I'll go into this area here. Okay, so I'm gonna find the panel ID here. So 105 objects connected to this panel, color code by circuit number. And no drawings does not mean no 2D. 2D is actually a very useful view of a BIM. And if you zoom in here, you will see the different circuits placed in a 2D view, and the tags you can add your choice. So if we add for deling, which is the electrical panel, and kurs number, and the type, which is TFM in Norwegian, you can tag that to your view. It means that you can create thousands of 2D views easy. This can also, of course, be saved as a view, and you can just change the panel number and you will see the tags. But it means that you have a view of the data, because this is data, it's structured data, and makes it useful. And this is useful when you install stuff, but it's also very useful when you're working as a maintenance person. If I switch off this circuit, what happens? What kind of components? So this is also a very, I would say, work with the data. Don't create static views of something that you can actually create a view of. But when you have structured data like this, where do you move forward? Well, the setup in this project, basically, is that you generate keys from the database, populate that into the design files, and then you share and publish it in an interface where you can actually grab them. But that means that you can also push those keys to other applications. maintenance, building automation. You can push it to anything. And then you actually get a quick connection to your graphical data, which is the model. So you can just plug it in and say, all right, so I have this ID. Where is that in the model? Can you show me a good legend of where my rooms are, etc.? So you get a quick connection to that. It means you can also replace your applications when there's a substitute, which is far better on some things. You don't have to spend millions on data migration. You can just plug in the data, populate keys, and then communicate. You have a view of the 3D as well. And we have connected this to the, oops, it keeps running. I'll hide this one. Okay, so what happens here? I gotta show you something else first. Because what I've showed you now is working with IFC data. And what's easy is to do stuff with data you can control. So if I, color code by floor covering. That's a very easy view. It's a property, something we control. But you can use data from other sources as well to do the same thing. 2D is very useful for this kind of things. You can see it in 3D, but it's less useful, I would say. But here are the different floor coverings you have in this facility. Now, what we do with Schneider, is use the data from the signal system. So these data here these are mechanical systems that are in Schneider. They are there because the data was pushed there from the Rofus. So they have the exact same IDs as the objects in Revit has and in IFC. But it means that you can go into a room, you click the link, and you fire up the Schneider, the room view. So this is the Schneider application, just showed in this interface. StreamBeam or other applications don't know nothing about this data. It's just the data presented in StreamBeam, where you can change temperatures, you can change sunscreening, you can do whatever, as long as it's connected. This is the alarms. And all the alarms are from Schneider. But since the maintenance ID is also in the model, we can ask, okay, where are these IDs in the model? And you can print them in a 2D view of all the floors. And you can be taken there, if this is a door or whatever, and filter data, because you're working with data, live data. And what BIM does is actually give all the data a location. The rest is just about presenting the data in a way that communicates what's urgent, what's important, what's not. So that's a door, as you can see. And you can then go to the door and you can take a closer look. Here was an alarm, so you can then zoom in. In the same way as you can work with components, doors, sensors, you can of course work with the data that are related. So if you have an electrical panel or a cooling system that supplies something, here you have the electrical panels presented with rooms. The only reason we can create this view of this is because the electrical panel has a relation to components in these rooms, and we can ask, okay, where are components that have a relation to this panel in rooms? And then we just present the room list as a legend for different electrical panels. On the right-hand side there, you have all the electrical panels for normal power in this floor. And this view on the left is something we developed. We would prefer Schneider Electric to create those views, but they are, the first version of the room, here you can see, by the way, a room with the deviation on the temperature. But this is data which is not in the model, it's just presented in the model, in context. So as you can see, the live data is promoted. Yeah, and you can do all kinds of things, CO2 levels, and other stuff. I apologize for the Norwegian terms here, but it's a Norwegian hospital, and the Norwegian maintenance personnel, they would prefer Norwegian. Yeah, and of course you can go back in time as well. You can slide it back and see when things started to happen, and you can also put data on top of each other. So when you have a temperature drop in the zone, you can then see which ventilation system is providing the zone or the rooms, and then do some error and search for the problems there. Yeah, door position status, but this is live. So now they're taking it, they're starting using this software as the building is handed over. And I think it's quite possible to make this happen as a one-time thing. The problem is actually to keep it alive. How do you keep the data alive when changes starting happening? And that was really the problem at the airport. When we started working with the airport, we found more than 30,000 component codes of objects that were gone, long gone. They were demolished, taken down, and the same will happen in this hospital unless you have a plan for how to keep that alive. And I think the key to keeping it alive is that you have one place to maintain a specific type of data. If you succeed there, you have a chance. Yeah, I'll stop this there, because the key here is really the setup here. How shall we maintain data? As Magne said, or explained, you can change data in a database without even touching a Revit. And the same thing you can do here. If you change one of those light fixtures with a new product, you just change the product in the database. And you can even do that from your phone directly to the database. You can change the property in the database. That is pushed right into the BIM authoring tool up here, and then published minutes later. It can be published into IFC. If you have, I don't know, you want to merge two offices to a meeting room, so you need to remove a wall. You capture it by BCF. That will be listening in on those that maintain those Revit files. Could be available seconds later. You remove the wall, and then a few minutes later, you can actually update the file on the design side. If the wall that you tear down needs to be removed from something, it is marked as demolished in the database, and it doesn't flow to the maintenance system. So a few minutes later, it will be gone from the maintenance system, because all those codes that should be maintained or should be operated, they will have a status code in operations. If you change that code, it should be taken out of the API and not distributed to those that use them. So you can actually control which components that are in the maintenance software from this central database, and it's reflected by the geometry. So this hospital will not only have the IFC format. IFC format is brilliant for archiving, but changing geometry is something you need to do in the BIM authoring tool, at least for now. The problem is not necessarily walls and columns and stuff. That's the easy part. The hard part is the MEP, where you have relations to systems, some structures there, which is hard to maintain with an IFC import, at least today. Maybe not tomorrow, but today it's difficult. So they will keep also their, in this project was a lot of Revit, some other software as well, but they will keep those native files available so they can maintain it in the native software as well. But the format they use for collaboration, for publishing, everybody works with, is IFC and BCF. And the database distributes the keys, and it enables what I would say is a common data environment where where people and software can talk together. But you need those keys. I'll show you a quick example of how they did their handover, how they managed. Oops. We're good. Yeah, so if we move in here again, look in the database, their systematic completion was done by changing status of objects in the database. So this is the web client of the Rofus. The BIM viewer or file does not know anything about this, but they have a parameter here that says how far in the handover they are when they're installing things. So F01 here just said that this is an object we want to trace or track as a systematic completion object. The rule was if it's member of 2 or more system, it should be managed in the database. It was 42,000 objects. F02 means it's installed. F03 means it's connected. F04, it's quality assured, and then you have the commissioning and testing completed on F06. This is something the electrical guy on the site installing did on his tablet. He changed status for the object. As soon as he installed it, he changed status. And I think it was 3 times a day, this status was exported to a dashboard from the Rofus database for all disciplines, so they know exactly how far they were installing and building everything here. And the next day or 2 days later, when the architect or the electrical engineer posted, synchronized with the Rofus and posted a new IFC, this became available as a property here as well. So you can work with that parameter. If you go to the process part here, you see it has a completion status here. So if we start with this control area and color code by the systematic status, you can see that there are 2 objects that are only in F02, but you see the rest of the status that you can find on this property. But it means that you don't need access to Revit to actually publish properties. Publish properties in the database, which is pushed up to the Revit and then published into the IFC as updated. And when you can do that, when people on site as maintenance managers, they can actually change data directly in the database without knowing anything about Revit. So what those that have the BIM authoring tool will have to do is just synchronize against the database, and it updates according to whatever the person on site or in facility has selected as a value or property. Yeah, I still have plenty of time. 10 minutes, yeah. Yeah, so, but I guess I've been talking too fast. I thought I had a bit short on time, so I'll open to questions from the audience. Yes, I think you need this. I'm not sure.
Osman Skorge from Statsbygg. You were talking about keys. What sort of keys are you using? Is this a get-in numbers or is it tag numbers or what is it?
Yes, it can be anything. In this case, it's a Tvärfaglighetsmärkesystem, TFM, classification system, but it can be based on any IDs. It can be the GUID from IFC, but not always trustable. You have the room IDs as well, which is the important ones. So what we need IDs on rooms, systems, and components. That's what we need unique IDs for. But it can be basically anything. It can be get-in if you want to communicate with the product databases. But you should probably have many keys, and you can use different keys for different applications. So, yeah.
You said the IFC GUID you don't use because you don't always trust it.
Yeah,
and I'm curious about that because we used to use a different kind of ID that was more text-based that users could actually futz with, but the global ID is a little easier to control from a kind of end user standpoint.
Yeah.
What do what were the downsides to the global ID that you were shying away from it from?
Well, we saw that it changed, and that's both implementation in software, but also human behavior. So if you want to move that light fixture, some electrical engineers will delete that object and make a new one, new GUID.
Right.
Or, especially in the system side, some of the softwares are really poor at maintaining that GUID, which makes it a little less predictive. And
that's what your API is doing, is it's assigning a
yeah,
unique
well,
ID.
we just tell, okay, look for this ID in this property, or in this property, or in that. You can basically choose, but we prefer the properties because they are not affected by poor human behavior in the same degree, and also easier to control than GUID.
That leads kind of to another question that I had. That it's for you guys too, if you want. But looking at digital twins, looking at this whole process, are you finding that there's a lot of training and education that needs to go on in terms of the users at the very beginning of the design process? We're building all this out, who sometimes sort of think in 2D, especially when you're talking about 2D documents and delivering those as opposed to delivering a model.
Yep.
Thoughts on that?
Yeah, I can give an answer there. I think
Sorry,
if you hand people something they experience helps them do their job, they will use it. And if people use it, you get good data, because then you get quality assured the data as well. So but obviously there's a different way of working, different mindset. Things need to change, and people are usually comfortable doing what they always done.
This picks up, I've been using the Rufus in another project, and I would say it takes a lot of training because it's a highly customizable database. You can put every data field in there. It could be too much, and it really takes a lot of manage. And for the Barbro project to get as far as they have, it's just because Helse Bergen or Sykehusbygg, they have decided their common data environment long time ago. They have this figured out, and that's what every other building owner needs to do themselves. And a comment on the IFC GUID. I saw Angel Veles from Autodesk. He's somewhere here today. When they newly have a couple of releases of their exporter saying, working with GUID consistency, that's one of the bug fixes. That tells me it hasn't been consistent. And that's because of work sharing in Revit. So when a user checks out a copy of the central file, makes modifications, another user does the same in parallel. Each of those two copies of the database generate GUIDs, and what happens when they merge. So that's one part of the problem with GUID as well.
Yeah. But I think it is important, as you said, make the decision, but somebody needs to own the process and where you want to go as well.
We throw this on most of our projects and things, and it seems like it takes a couple of projects for people sort of get used to their office, and we kind of try to minimize the footprint of people who are actually affecting the database.
Yep.
But now in this model, everybody's affecting it all the time. So
yeah.
I can see how you can go.
It's kind of democratized here, so everybody have access to. I think it's more than 1,000 users in this project.
Any other questions?
You said that the office was quite complex, but couldn't the interface be sort of made specially for the project, so you only have the fields you need and nothing else?
Of course, there are several different ways of customizing both data fields and filter on the data fields who could see what. But it needs to be set up. I've been to the last couple of years of the Rufus user days, and what has been discussed both times is how could we make this complex software simpler for the user. So that's in process, but they haven't succeeded yet. So what I tend to say about Rufus. It's a really powerful tool. Kristian has showed all it can do, but there are a lot of pitfalls.
Yep.
You could really screw up your project also if you do something wrong. But,
Yeah, I have to add, I used to be head of business and technology in the Rufus until 2016, so I'm partly to blame. Sorry. Yeah, but it's a lot of data. But I think as long as you have the data, you have the options to actually control it as well. And I think that's where the key is. It takes a bit of effort, training, and understand the mindset as well. That you can actually manage stuff from centralized.
I definitely think that not every parameter or what you need should be embedded into Revit and then to IFC. I think the solution is connect to an asset database.
Yeah.
I believe so.
Yeah, and listen in and just capture the data when they're created rather than going retro, populating stuff. So I think that's important.
I can really see the advantage of digital twins and these systems, but have you considered the cost of implementing it and the risk for not having it updated? And one thing is in a hospital, because the walls are basically always the same place and it's more or less just objects that's changed, and you can change them with only parameters. But another thing is an office building where you often change the walls, and sometimes you want offices, sometimes you want open spaces. What's the risk with this in a digital twin? Because you can have the sensor data and AI controlling the building without connecting it to a 3D model. So
yeah, that's the real question here, and that's also what we want to figure out with the further testing of POC and in other projects that might turn into a digital twin. And you're pinpointing the core of this. Both, if I invest in this technology, how can I be assured that it's not going to just be a very expensive gadget? How can I have a return of that invest? So for me as a BIM specialist, as I said, I want to take BIM into the operations phase. I want that all will be that it will be beneficial, and you will be dependent on that the BIM is trustworthy. And that raises the new question: what do you do when everything is changing all the time? And there will be technical solutions to that in the future, I believe. Maybe it's really easy to just scan the environment once a month and then auto-generate a slim BIM, and that's good enough. That might be a solution. We as a consultant, we could offer subscriptions, like always up-to-date as-built BIM. That might be a solution. Costly, maybe, but that's what the industry needs to discuss in the coming years, for sure. Yeah.
But I think the costs, we have seen the cost of not doing this. We know how things work or don't work today. This hospital was built for 70,000 Norwegian kroner per square meter. The rest of hospital Norway builds for 100,000 per square meter. So you don't see an immediate bad effect, at least, but these are pretty good. But I think we will learn more as more projects do what they have done. But so far, these are the only ones I know that has gone as far, both with digital production, but also with managing data through the process. Yeah.
Thank you very much to our speakers today. We're going to close the session now. Hopefully we'll see you in another session soon. Thank you.